Good day, class. You're welcome back to the second section of differential calculus. Here we are going to learn the techniques of differentiation. Basically, here we have four techniques of differentiation. We have derivative of sum, then we have product rule, we have quotient rule, we have function of a function. First of all, let us look at the general rule of differentiation. Let us look at derivative of sum. If y is given as x raised to power n, the rule of differentiation is that when you are differentiating y with respect to x, we write it as dy dx. The rule is that you transfer the power here to multiply whatever is the coefficient of x here, then you subtract 1 from the power. This is the general rule of differentiation. Let us take a look at some examples here. Number one, suppose you are given 1 over 4 x raised to power 4 minus 2x raised to power 3 plus x minus 5, and you are to differentiate it. Then you say let y be equal to 1 over 4 x raised to power 4 minus 2x cubed plus x minus 5. Now let us start differentiating. Then we have the y, the x is equal to this power 4. We'll come here and multiply this. We have 4 multiplied 1 over 4 x raised to power 4. We subtract 1 from the power, it will be x raised to power 3 minus this 3 will multiply this 2 to be 6. We subtract 1 from this power, it will be 2 plus when you differentiate this one, remember this one is raised to power 1. When you bring this one here, that one will come here. Then we'll subtract 1 from 1, it will be 0. It will be x raised to power 0, which will be equal to 1. Then when we differentiate a constant, is 0, no matter how large the constant is. When you differentiate a constant, it is 0. Now let us simplify this one further. We have the y, the x is equal to this, cancel this. We're now left with x raised to power 3 minus 6x squared plus 1. Then let us take a look at example 2. Y is equal to 1 over x. How do we differentiate this? Then we write this one as y is equal to x raised to power minus 1. Then we differentiate y with respect to x. We transfer this minus 1 here. This will be minus 1 times x, which is minus x. We subtract 1 from the power, it will become minus 2. Then when we write this one, this will be minus 1 over x raised to power 2. Now let's look at number 3 here. Number 3, if you are given y is equal to 1 over x squared, then let us rewrite this y as x raised to power minus 2. When we differentiate y with respect to x here, we transfer this minus 2 here to be minus 2 x raised to power. We subtract 1 from the power, it will become minus 3. When we simplify this, it will be minus 2 over x raised to power 3. Now let us take another example here. Number 4, if you are given y is equal to 1 over square root of x cubed, then we'll now rewrite this one as 1 over x raised to power 3 over 2. Then we'll have y as x raised to power minus 3 over 2. Now let us differentiate. The y, the x is equal to, you transfer this to this place, it will be minus 3 over 2. X raised to power, we subtract 1 from this power, it will be minus 5 over 2. Then we'll simplify this one further. We have minus 3 over 2x raised to power 5 over 2. Then it will be minus 3 over 2, the root of x, which is raised to power 5. Now, this is where I'm going to stop giving example on differentiation of sum. Now, let's go to the second technique, which is product rule. Product rule. If you are given y is equal to uv, u and v are multiplying each other, and both u and v are function of x, then to differentiate y with respect to x, now we have it as v the u the x plus u the v the x. What this means is You want to differentiate this one with respect to x, which is the u dx, then you keep this one constant. Then plus, you want to differentiate this one with respect to x, then you keep this one constant. If it is up to 3, you keep 2 constant, you differentiate the other one, then you keep another 2 constant, you differentiate the one you want to differentiate continuously. Now let us take a look at an example to illustrate this. If you have y is equal to x squared minus 1 multiplying 2x plus 1. Now this one will serve as u and this one will serve as v. Now to differentiate y with respect to x now is equal to, you want to differentiate this one, then you keep this one constant, which is 2x plus 1. You now differentiate this one with respect to x. When you differentiate 2x minus 1, it will give us 2x, because x squared will give us 2x, y minus 1 will be 0. Then you have done that, plus you keep this one constant, x squared minus 1, you differentiate this one. When you differentiate 2x plus 1, it will give us 2. Then you simplify. You have dy dx is equal to, when we open this bracket, this will be 4x squared plus 2x, then plus 2x squared minus 2. Therefore, we have dy dx is equal to 4x squared plus 2x squared, that is 6x squared, plus 2x minus 2. So this will give us the answer. These are the steps that you will take when you are to differentiate using product rule. Now the third one here, we are going to take a look at quotient rule. Quotient rule. When do we use quotient rule? We use quotient rule to differentiate fractional algebra. Take for instance, you have y is equal to u over v. Now and u and v are both function of x. To differentiate y with respect to x now is given by this expression v du dx minus u dv dx over v squared. Now let's take an example to illustrate this. We have y is equal to 1 minus x squared over 1 plus x squared. Now we use quotient rule for this. The numerator is going to be u, while denominator is going to be v. Now we have dy dx, which is equal to v. Our v is 1 plus x squared. Then the u dx, when you differentiate this one, it will give us minus 2x. Then minus u, our u is 1 minus x squared. Then dv dx, you differentiate v, which is 2x. Then everything over v squared, which is 1 plus x squared. Then you square it. Then we now simplify. We have dy dx is equal to, now when we open this, minus 2x times this is minus 2x. Minus 2x times x squared, this will be minus 2x cubed. Then we have minus into 2x times this, we have 2x. 2x times minus x squared, it will be minus 2x cubed. Everything over 1 plus x squared, then square. You don't need to simplify the denominator, just leave it the way it is. We have the x is equal to minus 2x minus 2x cubed. Open this bracket, we have minus 2x, minus minus becomes plus 2x cubed over 1 plus x squared squared. Then here, minus 2x cubed will cancel plus 2x cubed. Therefore, we now have the x is equal to minus 2x minus 2x. We have minus 4x over 1 plus x squared squared. This will be our final answer. Then the last method, which is function of a function. Function of a function. When do we use this? If you have something like this, you have y is equal to 2x raised to power 3 minus 3, let's say raised to power 5. Now, you replace this one with another function. We say let u be equal to 2x cubed minus 3. Then you now differentiate u with respect to x. We have the u, the x is equal to, when you differentiate this one, you transfer this one here, it will be 6. You subtract 1 from the power, it will be square. When you differentiate this one is 0, then you now have y is equal to, the whole of this one is u, then raised to power 5. Then you now differentiate y with respect to u. You have the y, the u is equal to, you transfer this one here, then you subtract 1 from the power, to the power 4. Then you have the y, the x is equal to the y, the u times the u, the x. When we substitute, the y du is 5u raised to power 4. The u dx is 6x squared. When we simplify this one further, we have 5 times 6x squared, it will be 30x squared, u raised to power 4. Therefore, when you replace your u, we have the y, the x to be equal to 30x squared. Then u is 2x cubed minus 3, then raised to power 4. This is the general method for solving this, but there is a shortcut for it. If you want to use the shortcut, what will you do? The shortcut for it is, you have y is equal to 2x cubed minus 3 raised to power 5. The shortcut for you to do this is, you say the y dx is equal to, you bring this one down to become 5, multiply by, you differentiate what is here. When you differentiate this one, it will be 6x squared. Then you rewrite it, which is 2x cubed minus 3. You subtract 1 from the power 4. That is the differentiation. And this gives 30x squared into 2x cubed minus 3, everything raised to power 4. This is the shortcut for this. We have another example here. If you are given y is equal to 1 over the square root of x squared minus 1. Do you know that this one can be turned to be in this format? Even though if it is not 1 over, if it is just the square root, you can turn it to be this format. How? If you simplify this one further, this one will be 1 over square root means raised to power a half. Then you have y is equal to x squared minus 1 raised to power minus a half. Can you see that this one is in this format too? Now let us quickly differentiate it. You say let u be equal to x squared minus 1, then the u, the x is equal to, when you differentiate this one, it will give us 2x. Then we'll have y is equal to, the whole of this one is u raised to power minus a half. Then you differentiate y here with respect to u to be equal to, you transfer this one here, we have minus 1 over 2, u raised to power, you subtract 1 from here to be minus 3 over 2. When you simplify this one further, this will be minus 1 over 2u, the square root of u raised to power 3. Now you have dy dx is equal to the y, the u times the u, the x. Then the y, the u here is equal to minus 1 over 2 square root of u raised to power 3 times the u dx is 2x here, 2x. We have the y, the x is equal to minus 2x over 2 the root of u cubed. These two cancel this, we have it as minus x over the square root of u cubed. Then you replace the value of u. Therefore, we have the y, the x is equal to minus x over the square root of, our u here is x squared minus 1, then raised to power 3. Thank you very much. So remain one section, the third section, that we are going to treat the types of differentiation. Thank you very much.